Good morning, students. This is Unit 3. The first topic is intersymbol interference ISA. In baseband, amplitude of the pulse varied in discrete manner according to the input binary data. The discrete PAM can have only two amplitude levels corresponding to binary 1 and 0. Then binary bits are combined into symbols. Finally, these symbols are constructed into signals. These signals are transmitted without any modulation. So at a time, how intersymbol interference is formed? So intersymbol interference is one of the error signal. Okay, so a signal gets dispersed while passing through the channel. So here, so simply we can say overlapping of pulses or symbols. Here this is the basic block diagram of ISI, intersymbol interference. Input binary data, that is B of K. So that is data encoding. The next process is data encoding. So BK is the binary data. So number of symbols, binary data, that is moved to the data encoding. So then it is output of the data encoding is denoted as X of T. Then it is moved to the transmitting filter HT of F. So up to this we can say transmitter section. Then next we move to the channel media, that is HC of F. Then after get channel output we can say X of T. Then it is moved to the receiving filter, that is HR of F. So the output of receiving filter is Y of T. So at a time we can give the sample at a time instant t equal to ITB. So Y of T, instead of that we can use it as a U of TA. Y of TA, that is ITB we can choose. Okay, so finally we go for this decision device. So decision device, it is decision is taken by threshold, that is lambda value. So finally we get the output binary data. So now we see about the calculation. Binary data BK is applied to the data encoder. The data encoder generates pulse waveform X of T. This can be represented by follows: X of T equal to summation K equal to minus infinity AK G of T minus KTB. Then TB is the bit duration, G of T is the shaping pulses. G of T, the in terms of that is time shifting property, we can say G of T minus KTB. So we can write it as a AK. AK is equal to plus A equal to BK equal to 1, minus A is the BK equal to 0, right? Then the signal X of T is passed through the transmitter filter, transmission filter HT of F, combine all the necessary filters. Then HC of S is the channel. That is, then the signal passed through the channel. The channel drives the signal to receiver with the has filter HR of F. The output of the RX filter is Y of T. These are the some parameter of those kinds of ISI block diagram. Okay, so Y of T equal to consist of original signal with noise. The signal Y of T is sampled at the T equal to ITB and is applied to the decision device, which compare the input signal with the threshold lambda. So see the lambda, that is the threshold level, that is if Y of TA greater than lambda means select symbol 1. If Y of TA less than or equal to lambda means select symbol 0. Okay, so consider the output RX filter is given by Y of T equal to mu summation K equal to minus infinity AK of P of T minus KTB. Okay, mu is the scaling factor, P of T equal to pulse shape. Okay, so these are all the frequency domain. There is mu AK P of F equal to H of F AK into G of F. Then we have some further calculation. Y of T is sampled at the T equal to ITB. Hence the equation 4 becomes Y of T equal to mu summation K equal to minus infinity AK P of ITB minus KTB. Here the TB is common, so we can modify the equation mu K minus infinity AK P of I minus K into TB. So rearrange the above equation and we can get the result like that. So finally we conclude, so mu AA is the errorless transmission. So remaining second term is called as the ISI. That could be solved by using the Nyquist criterion. Okay, so if the ISI is absent, then the second term will not be present, but it is not possible to eliminate in practical. The ISI can be reproduced by proper design of pulse spectrum filter, that is a receiving filter and the channel. Okay, thank you students.